This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to Software Engineering Radio. I'm your host, Giovanni Asproni. And today we'll be discussing identity orchestration with Eric Olden. Eric founded and scaled Secure and Clear Trust and Simplified. Simplified was the first identity as a service company. He served as a senior vice president and general manager at Oracle, where he ran the identity and security business worldwide. And he was also the co-author of SAML, the SAML standard, created the first pre-integrated single sign-on platform and identity fabric. Eric, welcome to Software Engineering Radio. Is there anything I missed that you'd like to add?
No, that was a great introduction, Giovanni. Thanks for having me.
Let's start with a refresher about identity management. So today we'll be talking about identity orchestration, which is about identity management. So I think it's a good idea to start with a refresher about what identity orchestration is, and maybe give also an example, a practical example, so our listeners will have a good mental model in their heads.
Yeah, happy to. So when you think about identity management first, and it's a simple concept of how do you manage what users can access and what they can do inside of an application. And that is the gist of identity management. Now, when you go further into the details, there's a good model, I think, of the 6 A's. So the first one is authentication. So how do you manage how you know a user is who they represent themselves? Are they using passwords or tokens? The second one is access control, and this determines whether a user can get to an application or to data that they're trying to. And third one is authorization, and most often this is, for instance, within an application, can a user do a transaction? Can they do a transaction for a certain amount of money or something like that? The fourth one is the attributes, and the attributes about a user that are used in these policy decisions is sensitive. So you need to make sure that those attributes are secure. The fifth one is administration or governance and how you manage those user accounts, who has membership in various groups and so forth. And then the last one, or the sixth one, is audit. And so you need to be able to see a log of what users did over time. And so taken together, these 6 A's represent identity management. So now the question of what is identity orchestration? And identity orchestration is a new way to think about identity if you have multiple clouds, if you have multiple environments and you're running in a distributed world. And so what we do with orchestration is similar to what the infrastructure world has done for some time. For instance, like using Terraform to automate and go do things in a particular sequence, or Kubernetes, which is another way to orchestrate your compute. So what we did with identity orchestration was say, well, why don't we apply some of those same concepts of abstraction and automation to the identity, so we can make these distributed multi-vendor, multi-cloud worlds work in a more seamless way. So some people talk about identity orchestration as Kubernetes or Terraform for identity. So that might be a good way to think about what identity orchestration can do.
So here we are talking about situation where we have different identity management systems, and identity orchestration is a way of actually making all these disparate identity management systems as if they were one somehow.
That's exactly right. And that we do through abstraction. So absolutely normalize the different APIs that the identity systems, the IDPs or the identity providers that they expose, created a layer that integrates across all of those so that when you build a new application, it doesn't have to be tightly coupled to any one of those identity systems. Instead, it talks to the abstraction layer. And through the decoupling of the application from the identity provider, it allows you to switch out different providers without changing the application. So you can go from an old to a new identity system behind the abstraction layer and not have to refactor or do anything to your application.
Okay. From a business point of view, what are the key challenges that identity orchestration helps to address? So from, let's say, non-technical perspective, more of a business perspective.
Yeah, I think one of the most common two use cases for orchestration is modernization. So taking your applications and moving them to the cloud. And in that world, you need to switch the legacy on-premises identity system with a cloud-based one. So modernization is a big, important use case because in the absence of an abstraction layer, you're going to have to rewrite your application. And that's very expensive, takes a lot of time. The second, maybe business scenario is with mergers and acquisitions. So when you think about one company acquiring another one, very often you'll find one company has a different technology stack than the other. And so you need to have a way to have these two worlds coexist. For instance, you may have one company that's a Microsoft shop. They use everything from Azure, including the Entra identity provider. And then they acquire a company that has been using Okta for years. And so now you have a situation where you need to make Microsoft and Okta coexist. As you probably know, those companies are very competitive and they don't like to play well with the other. Their answer is, oh, throw them out and put everything on us. But that's not practical for a lot of reasons, right? So from a business standpoint, the ability to be able to merge the applications and the different identity system allows you to handle these coexistence use cases a lot more seamlessly. And then the last use case I would suggest is when people are trying to get rid of passwords. And legacy applications often rely on password authentication. That's problematic because of phishing and breaches that come out of that weak credential. So a lot of great solutions on the market like passkeys and multi-factor authentication and tokens and all these really effective ways to eliminate the use of passwords. But the problem is you've got this new technology and you need to make it work on your old applications. And so in that case, you can use an abstraction layer to link up modern authentication with a legacy application. And so that allows you to increase the security very quickly and meet compliance from a business standpoint and eliminate the exposure to credential compromise that passwords have. So whether it's mergers and acquisitions, modernization, or getting rid of passwords, orchestration's been a very universal kind of tool.
Okay. So basically, if when we talk about mergers and acquisitions, is the situation where maybe you have employees that need to access systems of what was the other company before, but you don't want to give them a different set of credentials.
Yeah, absolutely. And it's as practical and simple as if in the merger and acquisition case, you have the new company and the old company, they have two different email addresses, right? Before the merger, they were different companies. So you may have someone like myself, I could have an account at Eric at Oldco, but I want to access the new applications and I don't have the Eric at Newco email address. And so what the orchestration layer can do is say, well, I know you're Eric at Oldco, and I'm going to map that to a different identity user ID in the cloud identity system so that when that user logs in, they get to the applications, but they use the old email instead of the new one. And it goes the other direction. So the new company has their emails will then work as an identifier for the legacy application. So namespace mapping is a very common, very hard to do problem if you don't have an abstraction layer that you can use to do that mapping. And so that is a really powerful use case for orchestration.
Okay, that's clear. And what are the main differences between systems that are on cloud and on premises? I mean, are there any key differences when we talk about them in the context of identity management and orchestration?
I would say in 2023, there's a lot of good options for different capabilities in the cloud. There's fewer options for systems that are running on premises because all the vendors have focused on going to the cloud. So you'll see more capabilities in your cloud identity systems than you will on premises in the legacy. Some of the key things that I think people get when you go to the cloud is someone else manages all of this infrastructure. And identity is one of the most mission critical parts of any infrastructure. If your security and identity goes down, your applications are offline. So you think about all of the redundancy and the resilience that you need to think about. I think the cloud-based identity systems have done a great job, and they have a really strong position in resiliency, but it's not always there. So another way to think about how to leverage the best of both of those worlds is you could use orchestration to primarily use the cloud identity system. But if there's a outage on the network, if a storm comes through and breaks the network connection to the outside cloud, then orchestration can fail that application over to an on-premises identity provider and go into more of a backup mode until your network services are reestablished, because you want to keep your applications up and running. So a lot of capability in the cloud, but now you've got a dependency on that the cloud is available in the network. And so I think the way to mitigate those risks is to be thinking about continuity, both at the application, data, and the identity layer.
Okay. Have you worked on any of these systems with mix on the cloud and on premises where you had to solve these kind of problems?
Yeah, we do it actually all the time. Some interesting use cases too. I think the most interesting one I found was in naval situations. So cruise ships, which was a news to me, are floating data centers, and they go out, and all of the kind of entertainment that you sign up for, and you want to watch a show or you want to get a reservation for dinner and all of that, that's all done now on your phone. And the identity system of all of these thousands of passengers who come on for a cruise and then they get off, you have a lot of churn, thousands of users that come in and leave every maybe a week or so. And the challenge is that when you're at sea, you don't have access to the cloud in a reliable way, right? They're nowhere near a fiber optic connection because naturally, they have to use satellites and things of that type. So that was a really interesting use case, because they said, well, look, when we have the ship in port, we can get all this really fat pipe data that we can synchronize things and do all of that. And as soon as we push off, we go to like 99% smaller bandwidth. And so that was a really interesting use case. When I was at Oracle, we did a lot of work with the military, and submarines have that same problem, because when they're underwater, by definition, they don't have communication anywhere. And so thinking about identity that works in both modes, connected and disconnected, it's kind of interesting in this new distributed multi-cloud world.
Must be also quite challenging.
Very challenging.
And as far as I know, also sometimes these systems have also software that is not necessarily the most modern stuff. It's like if you see entertainment things in the airplanes, they look like iPads, but from the 1950s, maybe, or 60s.
You're right.
So that might add an additional challenge to actually manage identity properly, I would imagine.
It is. You're right. And I think people get accustomed to how fast technology changes in the consumer world, right? Your phone, updating apps constantly, and the websites, they're always updated. But that's not the case in the enterprise. You go in the enterprise, these are applications. I've seen some that have been there for 20 years, and people don't know who built it. Well, they left the company a long time ago. So they don't want to touch it. They don't want to have anything go wrong. So they say, look, just don't touch that application. But we need to move it to the cloud. How are we going to do that? And so find some really interesting, kind of like imagine going to, you want to watch a streaming thing on Netflix, but then the only adapter on the back of the television is the RCA jacks. And those, I'm dating myself here, Giovanni, but you know how it used to be. Plug it in, the red, the white, and the yellow. And
I'm of the same generation, and exactly what you mean. Yes.
You're like, I just want it to work. And actually, that's a good metaphor for orchestration, right? If you think about a travel adapter. And the way that you're in Europe right now, I'm in the United States. And if I were to bring my laptop to London, I would have to have the British power adapter, which, by the way, is just not very efficient at all, my personal opinion. But I guess that's the American bias here. But so what do? I don't want to buy a new laptop that I bring to Europe. That wouldn't make any sense. So instead, I find an abstraction layer, a travel adapter. And that becomes the thing that I plug in the American plug into one side. And then I have various adapters on the other, and I'll stick it into the appropriate unit in wherever I'm going. And that's in essence what identity orchestration is able to do. You can plug the new stuff into the old stuff without changing it, because all of that mapping is done at the adapter or the abstraction layer.
Yeah. Yeah, it seems to be a good analogy, which actually brings me to a question that I had in mind. That is, are there any characteristics of the identity management systems that need to be orchestrated that make them more amenable to orchestration?
Yeah, I think if I were looking for an identity provider that is going to serve me the best, the one thing I would look for, Giovanni, more than anything is standards support, because it is the lack of standards-based integration that's caused so much of the headache. And so the standards, most of them all are supported nowadays, but the things that I'd be looking for are, does this provide SAML capability to do federated single sign-on? Does this identity provider use OpenID Connect? Does this identity provider support passkeys, FIDO2? If the answer is yes, then that's a lot easier to deploy and to switch because everything's based on standards. It's really, I think, when people are dealing with old and new, that's where a lot of the challenge is, because when we were building these applications 10 years ago, I mean, SAML has been around for 20 plus years now, but in the very beginning, it existed, but it wasn't widely deployed. And so it meant that people were using what they had, and that means cookies and proprietary authentication systems and sessions. And the only way you could pass data from the IDP into the app would be through HTTP headers. So you have to think about, how do you bridge that old world with the new? And when you do it in modern time, you'd be able to use, like, SAML is really well defined standard, and it handles all of the attributes and claims in a very secure way. So OpenID Connect, very similar, derivative in a sense, works really well as at the same token. The last, you mentioned APIs, and I think of the other key thing, not the first, but maybe the second or the third, would be the API availability. And modern ones today support RESTful interfaces more than the old days. There was a lot of SOAP, and that just was a lot more overhead to do a very simple thing. You had to do a lot of complex stuff. So look for RESTful interfaces that are also standards-based. So what I mean in that example would be, there's a standard for managing identity data called SCIM. I think it's a Simple Cloud Identity Management is the acronym. And that works with REST. And so I think look for a standard, look for a modern implementation, and you'll be in really good shape. If you don't, maybe you inherited something that was predated that availability, then use orchestration, and that'll get you to where you need to be. It'll basically bring standards to the legacy stuff. And I think that's really helpful.
And how does this work in the case of systems, actually, and also not so old systems, also some being created now, where people actually create their own identity management specific for the system? You know, they create a login, password, their roles, and everything, which usually lives in the same database as the rest of the data. So if you have systems like this, to bring them under an identity orchestration umbrella, what do we need to do? Is there some development work necessary there?
Yeah. So very often people have to build their own, and it usually starts like, oh, it's no big deal. We're building a trading application and someone has to handle the user table. And so they say, okay, let's just put a table in there and put our users in there and let's give them passwords because we want to focus on the trading application. That's really interesting. So they wind up rolling their own, and it generally doesn't have all of the capabilities that you would get from a third party. So I think one thing to do would be stop doing that because you're not really saving all that much and you're building a lot of technical debt that gets really expensive to replace. And so I think Auth0 has done a lot for developers who just want to solve that login problem, but don't want to spend much time doing it. You can get all the great capabilities from these identity as a service companies. Auth0 is a good one. There are others as well that are developer focused, some new startups that are coming out. But let's say that the ship has already sailed and we've got to work with that embedded user table. Then what I think one of the most important things would be to get rid of the dependence on the password. And the reason that is so important is that close to 90% of security breaches that lead to whether it's ransomware or other kind of privacy loss come from a phishing attack that compromised the password. And there's a whole host of reasons why that is so weak in terms of protection. But suffice to say that we want to replace that where we can with something that is more robust, like a multi-factor authentication, like the QR codes or the authenticator apps. So when you've got that situation, what you can do is use the abstraction layer to basically deploy software so that the multi-factor authentication is what the user experiences. They go through, they're redirected to a authentication process that says something like, check the authenticator app on your phone or look at this QR code or use your passkey that's built into your laptop, right? So there's any number of ways that you do that. So that is the secure thing. Now we need to link that trusted session with this legacy user table, right? And so at that point, what we want to do is look at that user ID in that user table. And we can ignore the password for a moment. So you look at the user ID and you map that to the user ID that is used for the multi-factor authentication. And at that point, you can pass that session from the authentication flow into the application using the user ID as the common link between the two. And so you can ignore the password because of the way that you deploy the orchestration software is in the same memory space as the application. So there's no way for someone to get in there and to put in a fake authentication saying, oh, I really did pass authentication. There's no way to do that because of encryption and trust and a lot of kind of the gory details that you don't have to worry about if you're using the orchestration layer because all of that is built into it.
Okay.
So the facade handles all of that.
This also means that there may be the need of some development effort of some sorts to be able to link the orchestration with this old ad hoc mechanism.
Generally not when you use orchestration software, right? Because that software has the ability to do the mapping and the account linking. And so it is kind of built into that layer. Now, if you didn't have orchestration software and you wanted to do that on your own, absolutely.
I'm talking about having orchestration software in this case. Okay.
Yeah. Using software helps you avoid custom code.
Okay. And now something slightly different. So how does identity orchestration affect the user experience?
Well, in the best of cases, the end user doesn't know that this is happening at all. It's the same experience before and after the deployment because the orchestration software is transparent. You drop it in front of your application. It works as a proxy or as an identity service provider kind of interface. So the end user, they go to the same place that they log in. And let's say originally they use a password, they go to a portal, log in. All of that is unchanged. What's happening under the covers or behind the scenes is that the orchestration software is saying, okay, I'm not going to go to the old system. I'm going to go to the new system to authenticate this user and to get attributes and check permissions and all of that. So transparent to the end user. And On the other hand, if you are changing the authentication experience because you want to bring in something like passwordless authentication, now you need to roll that experience out in a very thoughtful way. Because if a user who's used to logging in, seeing a username and password, all of a sudden has a different experience, we've been training our users about, hey, if the login page changes, you're getting phished, and don't put your information in there. And so you get into the situation where you want to be mindful on how to roll that out. And so I think there's a couple of ways that you want to communicate a change, like strong authentication or two-factor authentication is coming to our application. Tell people it's coming so they know when they log in that at some point they'll be given that option. And then you want to give them the ability to do both. Use your user ID and password, or you can use your passwordless token. And over time, they start to see those two, and then they go, well, maybe they need to, I don't know, just take a chance and try this new two-factor thing. And now all of a sudden they can start to use that one moving forward. So I think it's just getting around that conditioning of how you treat the end user. With employees, it's easier because you can force it. With customers, it's a little bit more, you want to incent them. So say, for instance, tired of forgetting your password, now just use your phone and it's more secure and more convenient. So you can incent people to try the more secure mechanism. But it is something you want to be very mindful, because you can get people, especially customers, to say, I'm confused. I'm not going to log in to this bank application because I don't want to lose my money. And I understand that. But if you educate people, I think there's a lot you can do to get them used to it.
Okay. And what about the case where you are integrating, say, a system where there are, already multi-factor authentications, but you have more than one? You have 2, 3, 4 because of, I don't know, a merger, an acquisition or something, and then you end up with systems that pretty much do the same thing, but maybe in slightly different ways.
Yeah, that's a very common problem, Giovanni. And it happens because human nature. I'll give you a great example. If we are all passwordless at my company, we don't have any passwords. All of our applications use two-factor authentication. And so, for instance, and I fly a lot. So if I'm on a plane and I need to access something, I need to have a fallback authentication mechanism in the event that I can't use a network-based one, right? And so I don't have my keys right here, but I have a FIDO token on my keychain. Normally, I like to use the Authenticator app that will go talk to the cloud and say, hey, here's a code that changes over time. And that's really easy, especially if I have my phone, which is generally all the time. But then I'm on an airplane, I can't get to the network. So it would be really useful if we can fall back to another multi-factor authentication mechanism, like my token that I plug into my laptop. So because what you don't want to do is say, I can't find my strong authentication system, so use my password. Because then that would just bring who's going to say,
would define the purpose of the authentication system in the first place.
So you can't do that. It's like locking your convertible, but having the top down doesn't make any sense, right? But orchestration in that situation can be the capability of the or. Use this mechanism or this other one, where both of these are strong authentication mechanisms. One could be an app, the other one could be a hardware token. But that is really important because people forget things, people go on airplanes. And so when you're thinking about how do we make sure that we have multiple ways that are still secure for a user to authenticate, that's where orchestration can really help you, in addition to the merger and acquisition use case that you talked about.
So you end up with a situation where instead of having the situation say, damn, we have redundancy, is a mess, you end up saying, luckily we have redundancy, so we actually have a way of avoiding disasters in case things happen.
That's exactly right.
So you can actually exploit that as an advantage.
Yes, you're right. Multiple is helpful in some cases.
Are there any differences in how orchestration works in the case of services instead of humans? When we have any kind of services connected to the network that needs some level of authentication, authorization because of the way they're done. Is there any impact?
Yes, there is. I think when you're talking about a service account or API, someone was joking saying APIs are people too. I don't know if I say that, but they have entities behind that, right? It's a user who's accessing an application that makes a transaction on that user's behalf. So what you have in that situation is a need for continuity of the user identity from the browser through to the back end, hitting an API that could be wherever and making sure that you can't do something at the API level that you couldn't do at the browser level, for instance. And so being able to have a way to basically move from the browser, have that session that then can be handed to the API layer, that's a capability that the orchestration layer can do. So that way you keep the consistency of the entity even as it moves from a browser to an API call. Another common thing is, well, what about just the API that's doing server to server request? And at that point, you put the orchestration layer acts as a proxy and enforces the authentication and authorization at the API layer. And so even without having a browser involved, you can still have the orchestration layer intercept basically the API calls and apply logic like authentication. When you're dealing with server to server, hopefully you're not using passwords because that's really bad security, but certificates are a lot more common when you're dealing with back-end entities, system to system. And so at that point, instead of using end user authentication, you're going to be relying on certificates typically. You could have some API keys, but that's just another word for a password. And so I recommend people avoid that anywhere, whether you call it a password or an API key, and instead use certificates. And that still applies in this world.
What would you do if you find the situation where you have really username and password for a service account? Because I've seen systems in the past where basically service to service, but still you needed to create basically a user for a service. Is kind of, a service is a person too kind of thing seems to be.
Mm-hmm.
So username and password. So I would expect some of those systems to be still out there, maybe not the most modern ones, but as we know, systems tend to live long lives if they're useful. So in those situations, how does orchestration affect the service-to-service interaction?
So I think in those cases, if I came into an environment and they had a lot of legacy, poorly architected because they're using passwords, one of the first things I would do is to replace the on-file system for the password with something like a vault and a key vault, a secrets manager. That's less about orchestration. It's just more about how you store secure secrets. And technologies, all the cloud platforms have them, key management systems on Azure. HashiCorp makes a really strong offering there. So I guess the reason I would start there is that you could, without changing a lot of the relying application, handle those sensitive data in a more secure way. So that would be the triage approach, would be to, hey, let's get this to be better than vulnerable as putting it on the file system or in some database or some user table. When you talk about orchestration, I think that also is a place where orchestration software can talk with those secrets managers and get those credentials for the service-to-service authentication. And so that's the second step, right? Put the vault in place, secrets manager, and then you get the orchestration to use that as well. And then you can extrapolate and go take those credentials and use them further afield. But you got to get rid of the vulnerability as much as you can where it's most susceptible in the file system.
And now something different about identity lifecycle management. So when we put an identity orchestration system in place, how do we manage the life cycle of the identity? Adding like onboarding, offboarding employees.
So I think the use case you're bringing up illustrates the dichotomy in identity, which is on one hand, you have runtime systems. So when someone is logging in, how do you authenticate them? If they're clicking on something, how do you verify access and so forth? And all of that's done at runtime. The other side of the dichotomy is in the administration side. If you go back to the 5 A's, that's, I think, number 5. And in the administrative side, that happens out of band. So typically a user will sign up, or you'll do a batch process and move a bunch of user accounts and do things like that. So the administrative side and the runtime side are decoupled by and large. And so you can use orchestration in both worlds, but you're going to be doing it in different ways. So runtime identity orchestration is going to handle I'd say the 5 A's that happen as people are using things. And then on the governance or the administrative side, you're going to be using the automation capabilities of orchestration. So for instance, you may have a situation where we're onboarding a new user, and here's where these two things come together. So we have a fictional bank, and the bank needs to verify information about the user so that the person can create a fraudulent account. And that may involve checking a driver's license in addition to some other information. And so you have this multi-step process or a user journey to sign up and get a new account. And we want to do this so that the user gets access to the account and they become a customer. So we don't want them to do it and then 3 days later have to come back and say, hey, your account is ready. We need to do this in near real time or just in time, the JIT approach. So what you could do is use orchestration to combine that user experience. They come in, they have a progressive profiling, a little bit of information. Tell us your username. Tell us what company you're part of. Tell us what state you live in or country you live in. And then as we start to get that information, that goes into the orchestration decision tree. And so, for instance, based on that information that we collected the first step, we may say, you're a European customer, so therefore I'm going to have you provide a valid European driver's license or whatever's appropriate. Take a picture of that, upload it, and then the orchestration software will take that image and then send it to an identity verification service, as an example. Wait to see if that checks out, and let's say that it does, then the orchestration system will get a response back from the verification system saying, yes, this is Eric, and I can say that worked. So the third step now is to issue a credential so that this new customer never gets a password in the first place. So at that point, we may, in step 3, enroll the user in a multi-factor passwordless credential. So for instance, hey, take a picture of this QR code and then do something on your phone, and we'll link that all together with this one transaction. So at the end of this 3-step flow, now the user has an account. They have been verified for compliance purposes, for Know Your Customer, and they have a passwordless authentication credential issued to them, all in a very seamless, transparent thing that should take maybe 2 or 3 minutes. And that is an example of where we're doing administration tasks at runtime, but being able to do them in a very specific sequence, an orchestrated sequence. That's an example of kind of runtime meets administrative. So you can do it all in a seamless way.
Okay, so the automation aspects actually help in taking care of the various identity management systems and their own specific needs. Because I guess the systems connected to those specific identity management systems need some part of the attributes or the information associated with the user, but not the rest. So
that's right.
And the orchestration knows where to look for all these bits due to the automation implemented.
That's right. And the way we think about those identity services, like the authentication system and the identity verification system and some others. So all of these are companies identity services, and they're all fragmented. They're provided by different vendors, they run in different places. And so part of what the abstraction layer is doing is creating what we call an identity fabric. So all of your identity systems, they're aggregated behind a common abstraction layer so that when it comes time to authenticate this user with this identity provider, create an account in this identity provider, issue a credential in this identity provider, the orchestration system is already integrated with all of those identity providers. So they can do the CRUD functions, the change, read, update, delete on those identity providers through this orchestration layer. So it's a really kind of powerful notion to combine abstraction layer with all of these infrastructure components it's integrated with and deliver it at runtime.
Okay, so now I was thinking a couple of questions. So one is the automation here, when we refer to automation in the context of identity orchestration is mainly about the administration bits. I would imagine also some of the other A's as well, depending on how you have to deal with the various APIs and things. But I guess for the administration parts is a big chunk of it.
Yeah, absolutely. And the typical use cases in user identity are creating new users and deleting users. So onboarding and offboarding, those are very essential. That's like the main two scenarios. And how you onboard a user, there's various steps, and often you have more than one system that needs to be managed. So that kind of orchestrating multi-step user journeys is really part of both the onboarding and the offboarding scenarios.
Yeah, because I can imagine that is where you really need a lot of automation if you have disparate systems to somehow synchronize to an extent with each other. But then I have now a question related to security here. Now, am I correct in thinking that having this orchestration layer that deals with different identity systems might actually help in segregating somehow information about the users? I mean, I don't know if I'm right or wrong, so you correct me if I'm wrong, but I've got in my head that if we had a single identity provider for all a disparate set of systems, each of them with its own specific needs and requirements for the data they need, this seems to be a big kind of a central point where pretty much everything about the user is collected, potentially a security risk in a way, or a privacy risk as well. Mm-hmm. But if we are orchestrating different identity providers, each of them connected to some systems, this somehow might actually help in segregating bits of information for the user in a way that makes it less likely to abuse privacy or security. Am I correct in thinking this?
Yeah, absolutely, Giovanni. And I think here's a thing that a lot of developers are surprised to find out is that even if you're working with a company that thinks of themselves as, for instance, an American company, there are a lot of potential European customers that come into this application, and an American company is subject to the European Privacy Directive, right? And so now all of a sudden, people in America think, well, why do I care about European Privacy Directive? Like, we're run this in the United States. I'm an American company. Well, it's because of the notion of cross-border access. And so when you think about this, it can be very expensive from a fine standpoint. I think the EU privacy, I just read this week about a social media company that had gotten a $370 million fine because they didn't keep the European data in Europe. And instead, it went to America and then to China, reportedly. So what do you do in that situation? Well, what you could do with orchestration is say, look, we have users that are European users. We're going to hold them in a identity provider that's entirely based in Europe and not in America. And then American identities will be stored in the US. We'll keep it simple, just those two places. So now that could be two different vendors. It could be the same vendor, but now you've got two identity providers that you want to access the same application, but maintain respect for the geography where those user and the data privacy rules apply. And so orchestration would allow you to link those two at runtime and not make you move and replicate data of European users into America and vice versa. So you keep it partitioned. That's going to save you a lot in overhead because of these European privacy directives, GDPR. There's a whole lot of reasons why that can become a problem very quickly. But orchestration allows you to choose what you want and use what you have wherever it runs. And so you can kind of have your cake and eat it at the same time.
And I guess this is possible because there is no need for the orchestration system to actually say that I have some systems for my orchestration deployed in the cloud somewhere in Europe. But to read data from the US the orchestration can simply ask questions about the user or things, receive back response. There is no need to use data in transit and so kind of read the data from the US and bring it to Europe, via the cables, and potentially causing all sorts of privacy issues or maybe legal issues.
Exactly. And I think the main thing is that orchestration layer does not persist. It is not an identity provider itself. It's like in virtualization, there's the hypervisor, and that runs on something else. It's not the server. It looks like the server, but it's not the server, right? It's a facade of the server itself. And what we do with orchestration is similar in that we're not persisting the user record from Europe in the America, because that's what the storage of data is a lot of the problem, right? If you're replicating user data, or someone says, hey, I don't want to have all of my citizens' data in a potentially foreign world. So that's where we, number one, never persist that data. And then the other part is that you can ensure encryption in motion and through the transaction all the way through, so that when that user is coming, we can tokenize that user's data. We don't have to use the data itself. And so a lot of ways to keep that information from moving from one geography to the other. And orchestration is right in the middle, making all of that happen. It's the connective tissue designed to do that very thing. And we've got a lot of our customers are multinational, and they run into this all the time. And it's really interesting how some of them have even used the same vendor, but have multiple instances where they've got the European instance of Okta and the American instance of Okta. They can't have the identities, even though it's the same identity system. They have to be in different places. And they use orchestration to say, sure, you will be able to link these, deliver that user into an application, but not violate the data sovereignty that is needed in that example.
Okay. And now a question about the auditing. So when you put an orchestration system in place, what happens to the auditing abilities? Because we had several identity providers, maybe each of those providing their own auditing mechanisms. What happens when you put orchestration in place?
Auditing gets a whole lot better. So the first thing is it's non-destructive, meaning all the auditing of the change logs and things like that exist before you deploy orchestration, those don't go away, right? All of those things continue to run the way that they always have. Now, when you bring in orchestration, you've got another layer where you can add more context. And this layer is going to show you the activity across identity providers. So it also means that you can see application access across different clouds. So why is that important? It's because you've got more of a single pane of glass now that you can look at all of these different systems and see how the information of the transaction could start on one cloud and end up on the other. And you can have continuity of which user account was used, even though it went to multiple identity systems in multiple clouds. So auditing gets a whole lot better. I think there's a really interesting opportunity for having a single view of all of your user access across your clouds and between your cloud and on-premises environments. And that's what you get with orchestration, because it creates a whole new layer of how you can manage all of these different systems, put it all into one place. And that breaks a lot of the problems of fragmentation that have been an issue where, hey, I see what's happening in this cloud, I see what's happening with this system, but I can't see the forest because of all these trees. What orchestration allows you to see is both the forest and the trees because it is managing all of it.
When we put identity orchestration in place, aren't we creating a bit more complexity in the system? I mean, we are putting more services on top of what was already there.
I think there's a good parallel between virtualization and orchestration. So it's true, right? You're adding software. And so now we got a new thing, orchestration, that we need to manage. But what it is itself is a management system. And so similar to the concerns that people had with virtualization, saying, well, we have all of these servers that we need to manage. And if we put them onto a hypervisor, we still have to manage those servers and the hypervisor. But what we found was that the hypervisor is the place to do all of the management. And so you actually have a built-in way to make things consistent. And that's similar to what we're doing with identity orchestration is we don't replace the identity providers. We create a new way to link them all together. And by doing that, we make it consistent. For instance, policy can be made consistent across these different fragmented systems using policy orchestration. And we help build a standard for that called IDQL. And that's a way to use software for free. By the way, it's all open source. And you can get the Cloud Native Computing Foundation. It's not a sales pitch. It's just like a developer tool for like, hey, you want to build cloud native apps? Here's a way to make your policies and all your clouds work consistent. And you couldn't do that without orchestration. What you would be doing otherwise is managing it in 5 different places. And with orchestration, you can manage it once, and the orchestration then propagates that change wherever it needs to go through. So you can reduce your management significantly by putting in a new piece of management software, the abstraction layer.
Okay, let's move to implementation. Yeah, just to have an idea of the work involved. Let's put things this way. So first of all, what are the typical components of an identity orchestration solution? So we have talked in the abstract identity orchestration, but in practice, what is it? When we have to deploy something, what do we get to deploy or to integrate?
So our approach to it, I could share that. I think there's other approaches that people have taken, but the one that we found after building these kind of systems for, exascale cloud platforms that like we did at Oracle to the biggest enterprises in various companies was to decouple the control plane and the management plane. And when I say that is the control plane is where you set your rules and your policies. And so these are the things that define how you authenticate, define what access control and so forth. And then on the runtime side of the enforcement, identity plane, depending on what terminology you want to use, we think of it as the identity enforcement plane. That's what happens at runtime. So the management structure in our approach is to use the cloud to configure your rules and then use a piece of new kind of software called an orchestrator that runs in various distributed places close to your applications. And this orchestrator is a multifunctional thing. It will act as a proxy, but it does more than proxy. It can act as a translation layer for translating different protocols into other protocols. For instance, changing a SAML protocol into an OpenID Connect protocol, right? So it's a translation server, if you will. It can act as a service provider like OpenID or a SAML SP. So it's this multifunctional piece of software, but the simplest way to think of it as like a proxy, right? And you can put this in proximity to your applications so that any traffic going into the application has to go through the orchestrator. Once that traffic comes through the orchestrator, it looks at the policy that it was given from the cloud, the control plane. And so it can read it without having to call home. That's the key thing. Distributed architectures, you don't want them all calling home because you lose the benefit of spreading things around.
And in this way, with the control plane, you can also change the way the orchestrators work without having to shut down the system and restart anything, basically. So it's a
That's
dynamic thing. So you can change policies or whatever you need to change without too much effort.
That's right. You change your policy and you publish that policy. And through the distributed architecture, that policy finds its way to all of the orchestrators that use that. And there's an air gap between the orchestrator and the control plane. That's important because if you're having to call home for every decision, that's not a distributed system. That's a centralized system. And you wouldn't be able to call home on a cruise ship.
So the orchestrator is a piece of software that is actually installed on the customer side, say, be it in the cloud or on premises.
Yeah, the orchestrators are distributed. In our world, the software that we've built, they're very high performance and they're very small. So you can run them on a cell phone. The whole distribution is not even 50 megabytes. So it's really intended to be very high performance. You run them in a series if you use Kubernetes, so you never have a single point of failure. And you can push them into these new form factors. I won't say this for sure, but don't be surprised if you see orchestrators in automobiles because cars are becoming even smarter. And another situation where you don't want to have to call home to a network to see if you're going to allow someone to have a local service to a music service or something like that. So if you have the right architecture, you can push a very small enforcement component out to all these millions of cars, to the 5G network towers, to mobile phones even. So it's all intended to solve identity in these highly distributed multi-cloud worlds. And you got to do it very secure, and you have to make sure that the performance and latency don't become issues. And that's why we took the air gap approach in our case.
How long does it take typically for a company to implement an identity orchestration solution?
Our record is less than 10 minutes to use our cloud service to get up and running and to protect a real live application. So we can do that using one identity provider and one application, start from zero, and you can be up and running in 10 minutes. That's our record. When you look at a big enterprise, their mindset is, well, we want to think, how do we do this for 5 identity providers and 200 applications? And so in that world, we call our approach anyways is called live in 5, which means 5 days and then you're production ready. So typically in the beginning, you're going to say, hey, let's plan our deployment. What identity systems are we going to integrate with? And what applications are we going to secure? The integration is plug and play. It's all visual. It's all you choose basically out of the fabric options, what you use. And so that's like a click operation. And then on the applications, what you need to do is provide basically 4 fields. What is the URL when people log in? What is the URL when they log out? What's an error page? And are there any areas in the web application you want to treat differently from a policy standpoint, like a dashboard versus a login?
So it's pretty quick. Now, a last question about emerging trends or technologies. In the field of identity orchestration, what is happening? Are there any emerging trends, directions, things, exciting things that are happening or going to happen at some point?
Yeah, there's a lot of really interesting things that are happening. I think the biggest is that people are understanding that identity orchestration is possible. When we first started this company in 2019, people said, there's no way you could do that. That's not possible. And we'd have to just let them use the software and say, well, and all these other customers are doing it. So it exists, it works. But that was a lot of convincing that we had to do in every individual case. Now, I think what's happened is that we've been able to make the software all self-service so people can just try it on their own. So that nice ability to give developers their own control over things instead of having to talk to a company, they can go do it themselves. We think that's really interesting. the whole self-service notion. And then I think the broader thing that I'm excited about over the next couple of years is using the capability of the orchestration data, all of that audit data we were talking about earlier, to aggregate that all in a common data lake. And what would you want to do with that? You'd want to train it to do some AI. And I know everyone's talking about AI. We've been very pragmatic in how we're thinking about it, because for us, it's a way to take our automation to the next level. We want to train it on what we do that no one else does, and that's deal with this data that comes out of these fabrics that we create. And so I think in the not too distant future, you'll be able to have an AI-powered co-pilot to watch what's happening across your orchestration world, all of these different clouds, all of these different applications, see when something weird is happening and do something about it automatically using orchestration. So we're kind of merging or converging the sensor and the enforcement and the integration all in one platform. And I think that's going to be the future, because the reality is, Giovanni, you know this, the bad guys are using AI and they're trying to get in. And so we are looking at how they're using it. And most of what we're seeing right now is they're using it to write better phishing emails. So we really are trying to encourage our customers, get rid of passwords. If there's anything I could leave your audience with, is come up with a password elimination plan as soon as you can. Because if you don't, these bad actors they're using all of these, hey, Chat GPT, write a really convincing phishing email. I think they probably won't write it in that exact words, but you get the idea, right? And all of a sudden, we've got all sorts of new attacks that are coming in. We got to get ahead of it. So being able to do something about it, detect it, and mitigate it, that's really where I'm excited with orchestration.
Okay, thank you, Eric. I think we did quite a good job in introducing identity orchestration. I certainly learned a lot during this interview. How can people get in touch with you to find out more?
Well, we have our websites. Probably the best place to go, strata.io, spelled strata.io.
We'll put that in the interview links.
Yeah, that'd be great. And then the other place would be the Cloud Native Computing Foundation for the standards around identity QL. I think that's the other place I'd point your audience to, the cncf.org. Look for IDQL.
We'll add all those links to the interview page.
Wonderful.
Thank you for coming to the interview, Eric. It's been a real pleasure. And this is Giovanni Asproni for Software Engineering Radio. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.